All right, good morning, everybody. It's Wednesday, September 2nd. We just had our first Zoom meeting. And what we talked about was the kind of math and the type of graphing we expect you to have to be successful with the first lab we're going to do. So it's really basically finding the slope and intercept of a line, which is something I know you did in Algebra 1. That's been a minute for several of you. There's also a couple specific questions for science we wanted to address. So that's what we went through. I made some notes for people. I first asked students to tell me whether they thought that was linear or not. And it's an ambiguous question because we don't know what X and Y are. If you think these are very precise measurements, then there's clearly some sort of curve going on. But with science, usually the data we're collecting are actual measurements and they have error in them. It's you reading a ruler, you reading a stopwatch, whatever. And that means you're sometimes going to over and underestimate. Really, since early elementary school, you've been told to do multiple trials, multiple runs so that your data is more correct. Well, this really shows what that means. And what we're going to do is try to fit a curve to it and find the equation for that curve. I don't believe physics should be, here's an equation, go use it. I think we should look at actual data, see if there's a relationship, find the equation that seems to relate one variable like X to a different variable like Y, and then use that to solve problems. So this is supposed to be linear with some error in it. If we think something's linear, we'll draw a best fit line. If you take a stats class, you'll learn how to do this with a computer or a calculation. It's called linear regression. You'll find the perfect best fit line. It's okay in this class and in other early science classes to eyeball it. We want to go kind of through the middle of all the data. You want to have about the same number of points above and below it. Don't force it through the origin unless you have a reason to. The intercept can often mean some things. So that's my best fit line. I had 10 data points. I've got about 5 above and 5 below. So at this point, the data is not important. And like I said, you overestimate, you underestimate sometimes, and the line going right through the middle of it shows how our data altogether gives us a good picture that avoids error as much as possible. For every mistake I made in one direction, I hopefully made another mistake in a different direction. And you basically use that line to determine what the equation is. So I don't care about data points now, I care about points on the line, and you pick the easiest ones to figure out, the ones that go through crosshairs. And then you get a slope, plug into the slope intercept form and get an intercept. And now you have an equation that's a model. I've had students ask, they've said other things that they've done in math to find equations. As long as it's equivalent to this, that's fine. There are different ways to do this, and I'll let you know if you're having trouble. The one thing that doesn't work, though, is just counting boxes like over 1, up 4. That's going to get you in trouble if the axes have different scales, which they often will in science. So you do usually have to use the slope calculation. What I have for next week for you guys to do, I have a graphing activity. There's graph paper you can print. If you don't have graph paper at home, you can print this. If you don't have a printer, you could take notebook paper and then make the vertical lines. But it is important we use a ruler and graph paper. So here's some data I'm going to give you. And most of this is just graph it, get the data, and then check it against my answer key. The last few questions refer to this video. And we'll make that guy be quiet for a second. Basically, you're going to be measuring time and position of an object as it moves. And we'll do that outside on the sidewalk. We're going to have people moving down the sidewalk outside our classroom, which is basically a giant piece of graph paper. And we're going to figure out how long it takes for them to get to various locations on that grid. And that'll give us our distance and time data, and it'll give us our first object to model and try to find an equation that describes its motion. I'm really glad you're here. I'm going to try to post these kind of summaries of what we talk about every week so that at least you sort of know what happened if you miss it. And I really hope you have a great Labor Day weekend. Thank you.